Hello, good afternoon. My name is Gustavo Vinueza, and I'm here with ModelRisk. ModelRisk is a quantitative risk analysis software that works on top of Excel, and it's built and developed by Bose Software. Bose Software is a software company, which its head office is in Belgium. We have more than 25 years developing it. We started as consultants and trainers in the quantitative risk analysis arena and evolved as developers of this software for risk analysis and risk management. Currently, we develop and support three software products. One is ModelRisk, the one we're going to see now, which has 18 years on the market. Then we have Tamara and Pelican, the first one, which adds a probabilistic layer on top of any schedule, right? So this is for schedule risk analysis, and Pelican, which is an ERM-based platform. And my colleague Timur is going to talk about that. Some of our clients, they come from different industries like food, like defense, insurance, finance, banking, retail, etc. And this is just to give you a brief idea that how agnostic our software is for the industry. That means that you can apply it in all of them together. We have a vision, and that vision is to develop the first ever complete risk analysis management and communication system. Some of the requirements that we've added to this vision is that it should be integrated, it should be web-based, it should be consistent with standards like ISO, COS, and PS340. It should be quantitative. That's the only way that we can achieve integration in the right way. Comprehensive, that means as a whole, it should be easy to use and flexible, right? To incorporate any type of risk problem inside. ModelRisk, the tool I'm going to talk about, is part of this Pelican system. It's part of this vision, right? That starts with Pelican. You see a little picture of Pelican over there. And what it is a complete web-based risk management software for companies that includes Monte Carlo Simulation, includes bow tie analysis, includes the quantitative part, plus all the qualitative and managerial part, like business units, risks, incidents, etc. Then we have Tamara. Tamara is our project risk product, which adds risks and uncertainty to my project plan. It communicates with Pelican through the quantitative portion. Then we have ModelRisk, which adds risk and uncertainty to my Excel models. And this is the one that we're going to talk about today, that also communicates with Pelican and communicates with Tamara. So with that, we generate a virtuous circle of risk management focused mainly on the quantitative portion, at least for the risk modeling and project risk. Of course, we have an API that you can communicate and integrate with your own applications. Now, a little bit of what ModelRisk does. One, of course, besides the risk quantification, simulation, and aggregation, it works on top of any Excel model with more than 100 distributions. That means that it could be used by beginners or it could be used by very advanced users. Users can easily include uncertainty and risk events. You can generate scenarios like for advanced sensitivity analysis using what we call VOSIM tables. You can use correlation and copulas, more than 14 available. And there's also complete reporting capabilities, both on the worksheet and with generated files like PDFs and Excel sheets. Is it simulation only? Of course, simulation is at its core. ModelRisk core capabilities are that, but we offer more things like that. For example, portfolio optimization using KPM model, integration with other tools like we saw before, time series modeling and fitting, which is something I really like. We have more than 30 time series to choose from. A data and results viewer, that means that you can explore the inputs and the outputs once they are simulated. We use simulation imported data management, which is called SIDS. That means that you have a complete manager for the simulations that you would apply to your models, and then you can compare ones versus the others. And finally, you have key drivers reporting. This aimed more for the decision-making process. Technical requirements, Windows 10 or 11, any Pentium compatible, hopefully an i7 or an i5. Memory, 4 gigs is enough. 8 gigs is optimal if you have big models, or if you plan to use different models open at the same time. I would say 16 gigs is good, so you can achieve optimal performance. Hard drive, we're not a space eater, and of course your models mostly are the ones that are going to occupy the space. Then we have a screen resolution, which is pretty much standard software prerequisites like .NET 8, 4.8. And we're compatible with Microsoft Excel 2013, 16, 19, and now Office 365. I'm going to do the demo in Office 365. Now, I'm going to show you the practical example that we prepared, which is a project assessment where there is a company, it's called ABC, and the company is trying to implement technological projects in company. That means that we are consultants in ABC, right? And we implement projects that range from 200K to 500K. ABC is awarded two big projects accounting for 1 million each, right? New regions, new teams, and of course this represents a risk because first of all, we already have three verticals: cybersecurity, data centers, and networking. Each one of them, and you will see, are more profitable than the others. And these projects are a little bit outside of our range, right? So typical questions will be, should we proceed with this project? Should we give it to another person? Should we be part of it, but not the whole project ourselves? So how do we calculate our total exposure? Is it okay to accept these projects if maybe they have a higher or a lower risk profile? You see, there are many things that you can extrapolate from this scenario, right? So how is risk being calculated for each project? Each project, as you will see, it has included uncertainties and risk events. That means that each project will have a distribution like this one here. This distribution will be generated for the revenue, for the cost, for the NPV, and you will see that we'll apply that to the model. And we'll have some ways of managing contingency levels. Like, for example, contingency is going to be at the P80, then we'll have managerial reserves, P95 minus P80, and the exposure is the maximum minus P95. That's mostly something like this, right? And you will see it. You see the mean versus P8 is our contingency, meaning that we're going to use this money the moment that we have risks that occur. Then we'll have the managerial reserves if this money exhausts, right? So this will be like knocking on the door and saying, look, I need more money because the project is being a little bit more risky than we anticipated. And so this is something that the company should be willing to put so the project can be finished. And finally, we have the exposure, all of this. And normally this portion here, this is the portion that normally we don't plan for, right? So this is the risk of doing business. Maybe in different countries, you will have this exposure, you will find it riskier than others. And this is something that we took into consideration here for the models. Right? Now, what we did for each one of the projects, because it is going to be a portfolio of projects, we added uncertainty and risk events impact. And I will show you that in the model. We have project one here. You see project one. And what we did, we added some distributions to it. You will see here, for example, for the product development first year, you see we have a distribution. We press here view function. Right? So you see that ModelRisk is going to be an additional tab in Excel, right, with all this functionality. And what I did is I just viewed the function because I already designed or defined a distribution. And this distribution is a per distribution that looks like this, right, between 45 and 55,000 or million. Then capital expense for year number 2, again, a view function, and this function would look like this, right, 90 to 110,000. So this is the uncertainty part, right? The uncertainty part will add distributions on top of the most variable, the most critical variables here. For example, the sales volume, just to finish, for example, we have a both per distribution there. Again, with view function, I can see the distribution, right, and see the parameters of the distribution. I can change it, I can shift it, you see? I can put some limits and boundaries, and so I can truncate them. So I have all this flexibility in the software. As you see, each one of them are connected in this NPV model. The NPV model has a discount rate of 10%. The discount rate is already, and it's the same for all the projects, right? So we have an IRR as well, and we have a cost, which is basically all the flows of the total expenses brought, right, as for today with the same discount rate. Now, this is for uncertainty, meaning that we are here, right? We are in the white triangle. And these are the natural oscillations of the variables. But on top of that, you can have risk events. meaning that you can have things that could occur that are not good with the project, right? Like, for example, technological obsolescence, a virus spread, implementation rejection problems, which is typical, right? Data center damage and things like that. For each one of these risks, we set up a probability or a frequency for the occurrence. We configure if they occur or not one or more than one time per year, you see here. So if the risk occurs more than one time a year, you see that we have a Poisson distribution, right? And if it occurs only once per year, we have a Bernoulli distribution. And what happens is, and I'm pressing F9, you see that these are the different scenarios that you will have. You see, like this. Now, for each scenario, for example, in this case, we have rejection problems, for example, in some of the years, right? We have some potential impacts. And what we did, we generated a range with minimum, most likely, and maximum, right, that it's going to be calculated here using a PER distribution, you see. So the moment that you have an event, for example, here, you see in strike, you have a strike, fourth year, right, and it's the fourth risk. So that means that this strike is going to cost us $17 million, for example, or you have more risks here. And what I added is I added this event magnitude cash flow, right, that is connected, right? This one here is connected back to my P1 here. You see, the one that reads risk register. So the moment that I, for example, I do this, you have 201, I come here, 201. Sometimes we have risks that prevent the rest of the project to be continued, like the merger risk. So that's why, or for example, the serious event on site. So that's why sometimes you have risks that prevent all the cash flows to occur. So for example, you have 44, 41, you come back to 44 and 41. Okay, in that way, we implemented this framework, right? You can profile risks, for example, here, as single, remember, it occurs only once per year. Multiple, it occurs more than once in different years. And of course, we use convolution. We use a simple multiplication for the singles, and we use a convolution for the more complicated ones. Here, you see, with applying the PER distribution, right? Now that we know how the model works, I've already run a simulation, and I'm going to show you a little bit more things. So as you see here, we have 6 projects. These are the 6 original projects that the company is working on. So you see here, you have this one. Project 2 is it's smaller. Project 3 is even smaller. Project 4 shorter. Then we have a big one. You have another one. You see, all the lengths are different, right? And then we have the projection for P6. I'm sorry, for P7 and P8, which are the new projects. And then we have a view like this. It's called portfolio, where you have all the projects, if they are active or not. So this is like a little dashboard. And then you can control here which project of the new ones are going to be simulated. If it's project 7 or project 8, I will show you that later. And here I have all of these reporting capabilities, right, after the simulation that you can generate. For example, here I have the mean, so I use both sim min. I have both sim percentile, so I can get P95, etc. I can calculate the exposure, right? And for each one of the projects, and I'm going to go to the project here, we have what we call an output. And the output is going to contain, I'm going to show you here in the results viewer, is going to contain all that information. Let me show you here. So this is going to be my NPV, right? My curve, and I will show you a histogram. Here you go. So in my first scenario, no additional projects, right? I have my NPV calculated here, right, which takes into consideration P1 only, right? And what I can do, I can change that to 0 if you like, right? I can edit this slider. I say, I want this value in 0. Why? Because you will remember that the NPV, if it's negative, you shouldn't do the project. If it's positive, you should do the project. In this case, we have probabilities. That means that if the project is positive, it says here you have 95% probability of being positive, meaning you have all of this on your favor, meaning this is a good thing, right? So this for project 1. If I go to project 2, maybe there's a different story, right? Let's see here. So you have project 2, 0 is in 89%. That means that it's a very risky project. That means you have only 11% probability having a positive project. And all of them are calculated like this, right? So the recommendation is always try to model everything at the most granular model. So you can do what we call here aggregation, right? I show you risks by the project, but I can show you risks by the portfolio. For example, here, I can show you, let me open the results viewer. right? I can show you all the different categories here. So you will remember that I had a sheet, which is called the portfolio sheet here, where I had my NPV. And my NPV, I have it by the project. You see here, remember? I can do it like this, or I can do it by industry. What is it that I did to get this? It's just the summation of my MPVs when it's cybersecurity, for example, here, you see, very positive one. Networking, not that good, you see, and data center, which is more or less in the middle. Of course, you can change the visualization like this, right? But you can see things by the project, you can see things by the industry, or you can see things in total. Remember that I have a total here, a total exposure, which is here, the company cost, or in the NPV. You see, you have 30% of risk. So you can aggregate, and the idea is that the moment that you have all these projects, you have to generate something like this, right? Like a dashboard where I have my outputs, you see here. This is my output for the NPV for each one of my industries and the total NPV. So that's why I could make this happen, right? Now, well, this is the project one that I just showed you. Things that you can do. You can generate a tornado chart like this. Let me show you here. You can generate a tornado chart, for example, for P1. And I will say, I want P1, right? And PV, I want to see the tornado chart, MPV here. You see? On this tornado chart, you can also play a little bit with the inputs here. And I will say, I just want my tornado chart to look at the variables that are uncertain, like the unitary cost, CAPEX, etc. Or if you want to include the risk from the risk register, you see you have the fire risk, but then you have the unit cost, the data center damage, CAPEX, etc. So you have everything combined as I was showing here. You see? So this is really flexible. This is, what I really like about this is that you can turn on off things, and it's really flexible. Right? You can generate graphics like the one that I show you, remember, with the three industries, right? And you can do that for NPV, for the cost, etc. Right? Now, if you go to the company level, and this is the one that I was looking for, right? So I can go back, and besides the NPV, that is the one that I was showing, I can show a histogram for the complete company like this. So in the portfolio, I can look at, first of all, the NPV, right? You know, it's 30% probability to be negative. Okay, that's the probability that I want to use in the last slide. Now I want to see the company costs like this. Take a look to the company cost. Right? The company cost goes from, you can have all the descriptive statistics here, from 1.7 million to almost 6 million here. Right? All this range. And also you can see a tornado chart here. Right? For the company. So I can change that here, and I can see the company cost and what happens with each one of them. So you can generate the same analysis as I did in all of them. If I like, what I can do, I can even see a box plot like this. You see here, this is for the company cost. But what I can do, I want another view, and I can say I want the box plot for the NPVs of each one of them. So I can do things like this: NPV, NPV3, NPV4, etc. So this is another view, you see, with a box plot chart, and then you can see how good or bad is each one of them. So you can have a lot of flexibility, as we were talking about before. All right. Now, key figures that we should calculate. Remember, is the exposure level. Remember that we have the P95, P8, etc. And I will see that in a second. And things that I did, let me show you here. We add the cost here. Uncheck all of them. You see? So when the portfolio went to company cost, which is this, I go for histogram, which is the same one. And I can add some sliders here So, for example, I can say I want P80, P95, and the mean, and then you can calculate, for example, here, take a look. You see, you can calculate the mean P80, P95, so you can create the same graphic I was creating before, right? Which is what I was showing here. And finally, what we did is we have already seen is the metrics and dashboard. And what we built 4 scenarios, and these 4 scenarios I will show you here are this, right? No additional projects, project 7 and 8 added, each one of them of both, right? And remember that we have this switch to turn on and off, right? So we're using something that's called a BOSIM table, which is basically creating scenarios inside the model. Right? So that means that in the first scenario, you see they are going to be 0, my switches, then it's going to be 1, 0, 0, 1, and 1, and 1. And what I did, I run 4 simulations. Here, you can control how many simulations you run. Right? I run 5,000 iterations for each, and I even can name the simulation with these names. Right? So that's why in the results viewer, you have these names. Right? What I did, I generated the mean for each one of them. What's the probability of being negative, right? Basically the risk. That's what I have here, right? The risk. The cost, right? The exposure for each one of them, etc. So you can decide here, you're actually helping the managers or the owners or the people that write the checks to decide and say, well, in this case, if we add only project 7, we're going to have to spend 49% more, right? Because that's the mean, right? The expected additional cost is 49%. But the exposure will go from almost 2 million to 1.8 million, which means project 7 has a good risk profile. Then if we add project 8, we're going to spend less, you see, less than the mean of the current cost, which is 35%, but it's a riskier project because the exposure, remember the exposure is the maximum of the distribution minus P95 is 25% more. So what is it that we're going to do? Because we can try to make only this, we can try this both, for example, by adding 84% with 123% of the exposure, almost 4 million. My recommendation, if you ask me, if this is a new risk and a new project, I would just go with this, right? Knowing that I'm going to spend more money, but I'm going to reduce my exposure, meaning that perhaps the project I'm going to do is going to be very beneficial. And that's why I will do it. You take a look here that if we add the project 7, our NPV being negative is reduced to 27%. Before we had it in 30. So that's something that we could only do with scenarios and things like this. Now, what else you can do to it? Here's the explanation of scenarios. So the moment that you receive this, you will remember. You can generate scenario comparison here. So if I go to the results like this, and I have, let's say, the NPV for the company, now I have another dimension here. And I can say, I want the NPV for the company with project 7, you see, project 8, project 7 and 8. You see, all these things, what you can do, you can disable the markers, so you don't have all these lines, like this. Just put that in 0, and you have something like this. So you see the NPV of the company. You can change it to a cumulative ascending curve, for example, so it's easier to see the moment that you have more than 3 or 4 curves. Or you can do the same analysis with the company cost, like this, you see? And then you change it to the histogram, and this is the same graphic that I have here. Right? Meaning that you can do this analysis, turning on and off the variables, and then turning on and off the simulation. So you have an additional variable there, like this. Right? Now, we were thinking about generating a health score, and what we thought is that you could create a proxy, for example, and this is how we decided, right? It's the total capital that we're going to spend additional for the project, because the project has a cost, versus in this case, the NPV risk, and of course, the required capital after the new awarded projects. That could be one way. Of course, this is something that we could explore, right? A health score. And finally, the probabilities of failure. And what we did is we calculated a complete NPV for the whole company. and we calculated the probability of being negative after we added each one of the risks. So for example, here, and I will show it to you, right? This is the NPV for the complete company, the one that we have here. So we decided this is going to be the best option. This one here, right? The probability of failure. When you add project 7, this is the best scenario. Right? So with that, I will say goodbye. Hopefully you like the session. This is a really, really powerful, flexible, and easy to use tool. Thanks again for the time, and we'll see you soon. So this is again ModelRisk by Vow Software. Thank you.